Students, this is Dr. Sourav's class. We are now solving the question paper of UPSC Mathematics Optional Paper, paper 2 of from 2024. So, hope you are doing well. Now, the question asks us to show that every homomorphic image of abelian group, that means commutative group, is commutative or abelian, but the converse is not true is given. This is a so I am so wrong here. This is a typo. Okay, so let us first establish that every homomorphic image of an abelian group is abelian. This means that if we have a group G and that is abelian, then we can prove this by taking any two elements H1 and H2 are let G and H be a subgroup of G, subgroup notation. Okay, that's not less than equals to here, that's not less than here is a subgroup notation. So now, which come from the elements G1 and G2, they are belonging to our G, then through respectively through our homomorphic image and our homomorphism, which is phi. Then because G is abelian, so we got G1 G2 equals to G2 G1. So our phi of G1, phi of G2 equals to our phi of G2 and phi of G1. Now proving that H is also abelian because this thing happens here. So our H is abelian. So the first part is done. Now we have to prove the converse is not true. Let A be a homomorphic image of a non-abelian group can be abelian. A simple counterexample is the trivial group, which is homomorphic to image of every group whether it is abelian or not. Okay, if we take our trivial group, it can map or it which is homomorphic to every possible groups. This is a subgroup also from them, but it's abelian or not, what? No. Oh, then sorry, it will be abelian, but the G is irrespective here, so it can be non-abelian also. Let us take our dihedral group D6. Then with from homomorphism identity, all the elements from D6, the all elements goes to identity. Then what happened? Then E is our abelian group, but this is non-commutative group. So our set statement says that every homomorphic image of abelian group has to be abelian. So our D6 is non-abelian, but our identity group is abelian. So that statements is not feasible here. So our converse is not true. We have proved that. Okay. Thank you guys. Hope you understood. And again, I am repeating the fact that the non-abelian group is our D6, and we can map or the every element of D6 is homomorphic to the identity group. Then the identity group is our abelian and our D6 is our non-commutative or non-abelian group. So our converse is not true. Hence, the first part is proven and the second part is also true that our converse is not true. Okay. Thank you guys.